ሰላም ወዳጆቼ ሀሳቤን ለተካፈላችሁ ሰብስክራይብ ላደረጋችሁኝ ሰብስክራይብ ላላደረጋችሁኝም አይታችሁ አስተያየት ኮሜንት ላደረሳችሁኝ ለሁላችሁም ሰላምታዬ ድረስ። ዛሬ ለመምጣት እንደውም አልወሰንኩም ነበር። ሌላ አንድ ፋክተር አግኝቼ የሚዘጋጅበት ፋክተር አግኝቼ እሱ ላይ ጊዜ መውሰድ ፈልጌ ነበር። ግን እንዳጋጣሚ ኢንትረስቲንግ የሆነ ነገር ፊት ለፊት አየሁና እሱም ማለፍ አቃተኝ። ኤኒዌይስ በኮሜንታችሁ ላይ የኦዲዮ ጥራት ጉዳይ ተደጋጋሚ ደርሶኛል። እኔ ከእግዚአብሔር ጋር ለማስተካከል እሞክራለሁ። ዩቲዩብን እንደ ሙሉ ጊዜ ስራ ለመስራት አይደለም የጀመርኩትና ጀስት ሀሳቤን የገባኝን ነገር የኔ አይነት አንደርስታንዲንግ ካላቸው ሰዎች ጋር ሼር ለማድረግ ነው። ነገር ግን አሁን የሚያበረታታ ስለሆነ የማየው ነገር በፕሮዳክሽን ደረጃ ለመምጣት እሞክራለሁ። እግዚአብሔር ይርዳኝ። ነገር ግን አስተያየታችሁን ለሰጣችሁኝ በጣም አመሰግናለሁ። እግዚአብሔር ይስጥልኝ። እሺ ዛሬ ያው ለረጅም ጊዜ የሰው ልጅ በቃ ማለት ይሄ ነጩ ዓለም በቲዮሪ ሲያብላላው ሲያሽከረክረው የነበረውን በፊልሞቻቸው ደግሞ ሎንግ ቢፎር በቃ ዶክትሪን ሲያደርጉን ሲነግሩን የከረሙትን ነገር ተግብረውታል እና በጣም የቅርብ ጊዜ ነው። አሁን 3 ወር ቢሆነው ነው። እኔ ዛሬ ነው በይፋ ተለቆ ቼክ ያደረኩት። ምንድን ነው የሰው ልጅ የኤአይ አርቲፊሻል ኢንተለጀንስ የምርምር ውጤት ባዮሎጂካል የሆነ ኮምፒውተር ቺፕ አስገኝቶላቸዋል። አፍተር ኦል ባዮሎጂካል ኮምፒውተሮች ጋር ኮንታክት ሊኖረን ነው ማለት ነው። እነሱ በጣም በደስታ ነው እንትን የሚያደርጉት። ለእኛ ለክርስቲያኖች ተስፋችን በእግዚአብሔር ለሆነ ግን ይሄ የጥፋት መለከት የሞት መለከት እንደ መስማት ነው። እኔ እንደዛ ነው የሚሰማኝ። በእርግጥ አሁን አሉ እዚህም ሰዎች አሁን ይሄ በቃ አድቫንስመንት የሚመስላቸው ለሰው ልጅ ነገ ጥሩ ነገር ይዞ የሚመጣ የሚመስላቸው ምናምን ሰዎች አሉ። ስፔሻሊ በቃ የተማሩ ይመስላቸው እና ነገር ግን እንደዛ አይደለም። ሰው ቆም ብሎ ካስተዋለ የሰው ልጅ ከተፈጥሮ ጋርና ከእግዚአብሔር አሰራር ጋር ሁሉ ጦርነት ውስጥ እየገባ ነው። አንድ የሳይንስ ሰው ሳይንስ ኢዝ አድቫንስድ ዋን ፊውነራል አት ኤ ታይም ይላል እና ወደ ሞታችን በየቀኑ አንድ ጊዜ ነው እያደገ እየወሰደን ያለው። ይሄ ሁሉ ለሰው ልጅ ምንም የሚያመጣው መልካም ነገር የለም ከተፈጥሮ አስገኝ ጋር ከአምላካችን ጋር ከማጣራት በስተቀር ማለት ነው። ኤኒዌይስ ምንድነው ነው አውስትራሊያ የሚገኘው ይህ ኮርቲካል የሚባል ላብ ከሰው ልጆች የወሰደውን ስቲም ሴል በላብራቶሪ ውስጥ ኮሎን አድርገው በኒውሮን ደረጃ ሲደርሱ ሴሎቹ ወደ ኮምፒውተር ቺፕ ጋር አዛምዷቸዋል ማለት ነው እና አሁን ባዮሎጂካል የሆነ ፕሮሰሰር ፈጥሯል እና ሙከራ አድርገዋል። አሳያችኋለሁ ክሊፑ ላይ ኢቨን ጌም ይጫወታሉ እና ገና በሲል ደረጃ ነው ያሉት። ነገር ግን ኦልሬዲ ትዕዛዝ መቀበል ችለዋል፣ ምርጫ መምረጥ ችለዋል። ሱን የራሳቸውን ኮንሽስነስ ማዳበራቸው የማይቀር ነው። የሰው ልጅ በገዛ እውቀቱ ነው ራሱን ወደ እስር ቤት እየወረወረ ያለው። ምክንያቱም እነኚህ ቢንጎች ዶን ነው አሁን ራሳቸውን በራሳቸው ማስተዳደር ከጀመሩ በኋላ ማን ነው መጥቶ የሚያድርባቸው? ምክንያቱም መንፈስ ቅዱስ የላቸውም። ምን አይነት ኮንሽስነስ ነው ሊኖራቸው የሚችለው የሚለው ነገር በጣም አሳሳቢ ነው። በፊልሞቻቸው ደግሞ በደንብ አድርገው አሳይተውናል። በደንብ ተርሚኔተር ላይ አይተናል፣ አይሮቦት ላይ አይተናል። ሪሜምበር ኦልዌይስ ያሳዩንን ነገር ነው የሚያኖሩ። ምክንያቱም ይሄ በቃ አስቀድመው ማዘጋጀት የሚባል ቲዮሪ አላቸው፣ ማለት ፕሮግራሚንግ አላቸው። ለዛ ነው አሁን ህይወት ፊልም እየሆነብኝ እየሄደ ያለው። ለእኔ እንደዛ ነው፣ ህይወት ፊልም እየሆነ እየሄደ ያለው እና ምክንያቱም በፊልም ያየናቸው ነገሮች ሁሉ እውነት እየሆኑ ነው። ማለት ስቲል አሁንም አይ ይሄ ጥሩ ነው ምናምን ብሎ የሚያወራ ሰው፣ እንደዛ የሚያስብ ሰው ሊኖር ይችላል። ነገር ግን ምንም የሚያመጣው ጥሩ ነገር የለም። የሜዲካል ኢንጂነሯ ዳንኤል ላዱክ ትባላለች እና ስለ አላማው ስትናገር በቃ መድኃኒቶች ለሰው ልጆች ወደ ሙከራ ወደ ሽያጭ ከመግባታቸው በፊት ይሞከርባቸዋል፣ ለዚህ ይውላሉ አለች። ለኮምፒውቲንግ ቴክኖሎጂ እናውላቸዋለን አለች። ሪሜምበር የአይጥ አይደለም የሌላ ምናምን አይደለም፣ የሰው ልጅ ሴሎች ናቸው እነኚህ ሴሎች። እና ክሊፖቹን እተወላቸዋለሁ። ኤኒዌይስ አሮን ነው ጀስት እኔ ግን ወደ ሞታችን በየቀኑ ወደ ጥፋታችን እየበረርን ያለ ነው የሚመስለኝ። አንድ ላይ ባክ ቱ ባክ ሁለት ክሊፕ አጫውትላችኋለሁ። መጪው የጾም ሳምንታት ለክርስቲያን ወዳጆች መልካም ጊዜ፣ ጸሎታችሁ የሚሰማበት፣ ጥያቄያችሁ የሚመለስበት ሳምንታት እንዲሆን እመኛለሁ። ድጋሚ እስከምጣ ድረስ ሰላም ያገናኘን። ባይ።
If you're watching it from 2199, this is about how the Matrix started for us. There is a startup in Australia who are actually growing live human neurons and then integrating it in a traditional computer chips in order to advance AI. Seriously, this is the closest thing to the Matrix I've ever seen. What happens when you put a biological brain in a computer chip? Let's find out. In designing modern AI chips, we derive a lot of inspiration from humans' brain. We are trying to replicate it in silicon, to replicate it architecture and computing schemes, and finally to fill it in with mind. Cortical Labs, a startup based in Australia, is building so-called dish brain chip. They grow a group of neurons, so brain cells, in the lab, and then they incorporate it into a computer chip. And it works because both computer chips and neurons communicate with electrical pulses.
I'm not sure if you've heard about the Matrix, but the original pitch for it was that people were being used as computers by the machines. What we're doing is closer to the spirit of the Matrix than the original movie.
The major advantage of this approach is that neurons can actually think on its own. They can change its shape, grow, replicate, or even die in response to the demand of the system. At first, Cortical Labs use neurons from mouse embryos, but right now they are using only human neurons in their chip.
We did find that the cells from people had a 30% increase in learning rate compared to mouse cells.
Good news, there is no brain invasion required. Cortical Lab team grows neurons artificially, but they turn
fast, powerful, and efficient at the same time. These are exactly those properties that computer scientists have wanted to recreate since the 50s. So they created artificial neural networks, where many small computers connected to each other should mimic the brain. Since it was very hard in the beginning, it would take decades until processors and memory storages were developed that had the capacity to power artificial intelligence as we know today. Even if artificial intelligence, also called deep neural networks, is changing our world rapidly, it is still no contender to our biological example, and computer scientists keep working on the development. For example, reinforcement learning, a learning method of humans and animals that enables AI to learn decision making. It can learn, for example, to play a game just by playing it. On the hardware side, they work on so-called neuromorphic computing. Other than traditional GPUs, graphic processor unit, they communicate information by using small voltage spikes, exactly as neurons do it, with the expectation of making artificial neural networks faster and more efficient. Summarized, huge efforts are made to mimic the biological brain, but also hangs far behind, at least in most cases. But wait a second, why not just skip all the development work and connect a biological network into a computer? You think that sounds like crazy science fiction, don't you? But this is exactly what a company called Cortical Labs, based in Australia, is currently working on. First of all, the idea arises, of course, some questions. Are brains and computers even compatible? On one side, you have a logical computer system made of software, hardware, and memory storage, implementing transistor technology. A computer is basically made to solve arithmetic operations. On the other side, you have an organically grown network of neurons, where no borders between hardware, software, and storage are existent. Nervous systems have developed to make complex decisions and bring them to action fast. While a computer has no problem calculating big numbers, most of us have trouble just multiplying 4-digit numbers. In exchange, we can walk and talk at the same time without the need of connecting ourselves to big, gigantic supercomputers. But in spite of the big opposites, the link between brain and machine can work. The key word is brain-machine interfaces. Brain cells communicate through so-called action potentials. In a nutshell, it's basically short voltage spikes. We can already measure these action potentials as well as trigger them by putting electrodes to the brain and applying short voltages from outside. Both input and output can be done by the same electrodes. Now, we just have to link a computer in to analyze and control the neural activity. Well, the brain-machine interface is ready for action. Although brain-machine interfaces have been researched for a long time, only the cochlear implant has made it to mass adoption. There are also experimental projects where test participants can control prostheses just with their minds, a robotic arm or a leg, for example. Also, Elon Musk's Neuralink is currently working on a brain-machine interface, which of course will be able to do everything at some point. This monkey, for example, can play mind pong with it. So these are some proofs that the link between brain and machine is possible. But the team of scientists at Cortical Labs wants to network into a computer, not the whole brain. That would be a bit of an overkill. To put it plainly, they want to integrate brain cells into a motherboard, like a graphic card. To do so, firstly, they have to put it in a small, controllable environment. And secondly, they have to make sure to adjust those brain cells into the interface of a computer. This is where multi-electrode arrays comes into play. These are circuit boards with dozens of contact points. On these boards, you can place flat preparations like slices of brain cells, for example. During this experiment, the sensitive tissue is kept at the right temperature and applied with a nutrient solution that also contains oxygen to nourish the brain cells. With this approach, neuroscientists have discovered a lot about the functionality of neurons. The preparations described are still coming from animals, which unfortunately have to die for these experiments. But modern science already has a solution for this ethical problem. It's called pluripotent stem cells. They can either take these from animal embryos or even better, from human skin, so that no animal is involved in those trials anymore. With the right processing, they can make neurons out of these stem cells, which can be added on the multi-electrode array, and with the right electrical stimulation, they can finally control the growth of these cells. This is exactly how the Australian company Cortical Labs integrated biological brain cells into a computer. They call their invention dish brain. No, they don't serve you brains in a dish. It's only the ironic approach of the scientists. And the question remaining now